Today's topic of discussion is degrees of freedom. It is defined as the total number of coordinates required to specify completely the position or configuration of a moving system. For example, if you consider an ant moving along a wire, then the ant is moving with the wire only. So its dimension, its direction is in one direction, is only in one axis, and we require only an x-axis to specify the motion of that ant. But suppose if the ant is moving on the floor, then we will require two coordinates x and y to specify the position of the ant. And suppose if the ant is moving in space, let us consider, assume it cannot move in space, but suppose if it is moving in space, then you will require three axes or three coordinates x, y, and z to completely specify its position or configuration. So this, the number of coordinates denotes the degrees of freedom of motion of a moving system. Now this was for translational motion. Suppose if a body has a rotational motion as well, if a body has rotational motion as well, then the body can move along can rotate along three axes. If this is one axis and this is another axis and this is another axis. So if these are the three axes, then the body can move along, rotate along this axis. The body can rotate along this axis, and the body can rotate along this axis. So it has three degrees of freedom due to its rotational motion also. So a body can have in total 6 numbers of degrees of freedom, 3 rotational and 3 translational. Right? Maximum degrees of freedom a body can have is 6, 3 rotational and 3 translational. Now, let us see the degrees of freedom of different gas molecules. Now, for monoatomic gases, the molecule contains only one atom. Thus, it cannot possess any rotational or vibrational motion. Its motion is wholly translational. So, a monoatomic gas molecule has only 3 degrees of freedom. Now, for diatomic gases, what happens is that the diatomic gas molecule consists of two atoms which are bound together, right? And it is in the shape of a dumbbell, and it has two axes along which it can rotate. These are the two free axes along which it can rotate, and it has 3 translational degrees of freedom as well. So it has total 5 degrees of freedom. And if we go for a triatomic gas, now the triatomic gases, the atoms can be arranged either in a triangle. If they are arranged in a triangle, then the degrees of freedom is 6. If they are arranged in the form of a triangle like this, the atoms are arranged in the form of a triangle, then the degrees of freedom is 6 degrees of freedom. And if the atoms are arranged in a straight line, if the atoms are arranged in a straight line, if the atoms are arranged in a straight line, then they have 7 degrees of freedom. Then they have 7 degrees of freedom, right? Then they have 7 degrees of freedom. 1 degree of freedom is also rotational about its own axis. About its own axis. 3 axis and 1 axis can itself. 1 axis is the axis of itself.